Good morning, dear students. Welcome to this session on prestressed concrete. Uh, we have completed the unit 1 with the last session. So today's session, I'll just recall all the 17 sessions, whatever have taken on the unit 1. Okay, just run through the slides, what are all topics that we have discussed. Okay, just a recap of complete unit 1 content. That's it for today's session. So coming to the topics of unit 1, so we have talked about the basic concepts in pre-stressing. What exactly is pre-stressing? Then your syllabus consists of advantages and applications of prestressed concrete, and then high strength concrete to talk about permissible stresses and shrinkage, creep, deformation characteristics of the high strength concrete. And the last content is high strength steel types, forms, strength, and permissible stresses, and the property called relaxation of stress and cover requirements. And above that, we have also discussed durability, fatigue uh, related content with this high strength steel. This is overall unit 1 syllabus. So I'll just run through the slides, whatever we have been into this contents. Okay. So the basic concept is introduced first. What is pre-stress? Okay, and before actually the pre-stress concept to the concrete, where else we have used prior to concrete. Okay, that is what is this we have talked about. And then the early attempts, how were they? You know that early attempts of pre-stress were failure because of the losses prevailed in the pre-stress. So the normal steel, whatever is available at that time, was not sufficient for pre-stressing purpose. Whatever we induce the pre-stress is everything lost, and finally it is becoming just a normal member. So that's why uh, uh, there is a need for high strength steel, uh, because we are losing the pre-stress whatever is induced with the normal steel. So as we are using high strength steel, which means high intensity of stresses are to be induced into the concrete, so concrete shall also have this the similar strength to take that much of pre-stressing force. So high strength concrete is the requirement in turn with the high strength steel. So this is what is the basic basis for need of high strength steel and high strength concrete. And we have talked about the history also, how the development of pre-stressed concrete, and the father of pre-stressed concrete, Eugene Freycinet. Okay, and the related content. Okay, development of building materials and forms of pre-stressing steel. Again, the same content is discussed extensively in high strength steel topic. Okay, and interfaces, stages of loading, and then coming to the advantages of pre-stressed concrete is discussed, and then limitations of pre-stressed concrete is discussed, and applications of pre-stressed concrete is extensively discussed with suitable diagrams also, possibly wherever they are being incorporated. Okay. Similarly, uh, taking up the next content where high strength concrete uh, is started discussing. Okay. So in this high strength concrete, okay, so that was about basic concepts, covering basic concepts and advantages, applications, and all. Along with that, also a little more extensively, brief history and everything was discussed. Now we are into this high strength concrete, where all these are being discussed extensively, where the permissible stresses, shrinkage, all this creep property and deformation characteristics. Okay, that is into this high strength concrete. So discussion on high strength concrete. So to start with, we have started with very basic content. What are the constituents of concrete, and then what each individual constituent is like, requirements, and pertaining to particularly referring to IS code wherever it is required. Okay, so remember, IS 1343 2012 is the code that you have to use, and for all references regarding this pre-stressed concrete. Okay, so have a copy with you wherever for ready reference. And then cement, types of cement, water, and what type of water is required, and how you decide suitability, admixtures. Okay, properties of hardened concrete, strength properties. Okay, compressive strength and tensile strength. Okay, stiffness property, durability of concrete. Okay, where stiffness of concrete is again from clause 6.2.3.1 from the IS code. It is to be taken as 5000 root FCK. Right, and durability requirements depending on the exposure. Again, this will be extensively discussed with the code. Okay, along with the help of the code. Okay, and the exposure, when there is exposed to severe environment, how the need of limitations on cement and water cement ratio will change, and you have to note that the change in the maximum cement content from 530 kg per meter cube, it was in the earlier code, is now reduced to 450 kg per meter cube of concrete in this IS code. Okay, similarly, the other type of concrete called high performance concrete, wherein the following are the types of high performance concretes. So there is a lot of scope for your projects in this high performance concretes list. Okay, and further, the research is also possible in this areas. Okay, then permissible stresses in concrete is being discussed along with the code involvement. So the code specifies uh, the compressive stresses in concrete shall be limited to so and so values depending on the pre-tensioning or post-tensioning activity, and also at transfer and also at service loads. Okay, so this is extensively discussed. Uh, Follow all those lectures which are completely discussed all these contents, right? And pertaining to tensile stresses, there are three types of members we have in this category. So where you don't allow any tensile stresses, that is type 1 pre-stressed concrete member, and then type 2 pre-stressed concrete member, where we permit very little value of tensile stress to develop, that too without cracking, and type 3 members are cracked members. Okay, where we permit the cracking. Okay, so started discussing about shrinkage property. of the concrete where it is necessary because you are losing the pre-stress because of this property of concrete. So how shrinkage affects the pre-stress value, that is being discussed, and how to calculate the shrinkage strain. Okay, so there are basically two types of shrinkages, and autogenous and dry. So drying shrinkage and autogenous, and the related IS clauses on this shrinkage property also is being discussed. Okay, then creep property, where creep of concrete is something like relaxation for steel. Okay, so increase in the deformation with time under constant load. Okay, so creep is a property of concrete, and whereas relaxation is property of steel under the similar conditions. Okay, which means sustained load on concrete, sustained load on steel, increase in deformation, and whereas increase in strain value in steel. So where for concrete we call it as creep, for steel we call it as relaxation. So how to calculate creep of concrete? This is also one of the important aspects to control losses. Okay, so creep property is defined with creep coefficient theta. Okay, and dependency on different parameters. How to read a value from the table, or else how you calculate the creep coefficient with the different formulas. Okay, with time, or else final values, all that. Okay, so this is in detailed calculation for creep coefficient value and creep loss. Okay, and deformation characteristics for concrete. Okay, is by figure 3 of IS code, and this you have already used for concrete. Same uh, the IS code IS 456 whatever gives you the similar curves are being given by even IS 1343 also. Okay, so characteristic compressive strength, and then size effect is involved in this. Hence, a factor of 0.67 is involved, is included, and then finally material factor of safety uh, for obtaining design stress strain curve. This is the design stress strain curve. Okay, and then equations, if you want to have an equation for to develop an equation for stress strain curves, or if you want a particular value at some location to exactly know what is the value of stress there, just substitute the strain, get the stress value. That is this equation. Okay, similarly for high strength concrete beyond 100 megapascal. Okay, this is the equation for that curve. So this is about stress strain property of concrete. Okay, and grout is also one of the important aspects, where what are the properties of grout it shall have. Okay, so all these is the content which is related to high strength concrete. Okay, then going for high strength steel is the content that we have been discussing in the last few sessions. For high strength steel, types of high strength steel, and then strength properties, I mean strength of high strength steel, strength values, permissible stresses. And just like creep for concrete, there is a property called relaxation of stress and cover requirements for steel. Okay, so these are the things which I've been discussing for few sessions in the last few sessions, right? So high strength steel, we started with the forms to talk about wires, strands, tendons, and cables, bars. Okay, what are they? And a pictorial representation is also being given here. Then types of pre-stressing steels depending on their treatment processes. Okay, and IS code classes on that. So class 5.6 talks about these types, and then properties of pre-stressing steel, how the properties should be. Then strength of pre-stressing steel is tested with this type of testing machine, which is very similar to our UTM, Universal Testing Machine, where we'll be testing the bars above 8 mm, like 10 mm bar, 12 mm bar, likewise. Whereas this machine is used for testing the wires which are below 8 mm dia, right? Up to 8 mm dia. Okay. And then the strength values from different IS codes for different types of steels, okay, are discussed. And then stiffness properties of pre-stressing steel, where nothing but Young's modulus values, difference between the earlier code and the new code, okay, where new code says it shall be obtained from the manufacturer, okay, right? And then permissible stresses in steel, earlier code it says 80%, and the latest code says is 76% is to be limited, the value of the pre-stress that you induce in the wire, okay, the stress that is to be induced into the wire, okay. So that is a change in the IS code recommendation. And the yield point, as you know, for high strength steels we don't have yield point, specified yield point, so we take 0.2% proof stress as yield stress, right? And this is the curve that is being used for all stress strain related values for pre-stressing steel, okay. And you can see that this is 0.2% line where it meets 90% of the ultimate stress, right? So this is what is the stress strain curve, and its dependency on the treatment process is discussed. And we have discussed to obtain design curve, what is the value of material factor of safety to be used. And then comes the relaxation of stress in steel. So unlike creep, similar property, time dependent increase in steel strain at constant stress, okay. So and relaxation values, how it will depend on it will depend on the rate of loading. If you slow down the loading process, the relaxation loss will come down, and also the value of the stress that you induce, if it is no less than 60%, you don't expect any relaxation loss, it is zero, and that is given here. So for 50% it is zero, and if you induce 60% of characteristic strength of steel into that, it will have a loss of 3%, okay. So relaxation loss in terms of percentages, okay. Whereas there is a type called low relaxation steel, for that the values will be almost half is the value of loss, so you can have low relaxation losses. Cover requirements, the IS code is talking about the cover requirements for protecting the high strength steel, okay. And there are two major concerns with the nominal cover to be provided to meet the durability requirements is one aspect, and fire resistance is another aspect. So these two aspects are given in terms of tabular values, where table 16 and table 16a will talk about these two. So durability is like exposure, okay, and fire resistance is like number of hours that it can resist when a fire broke out, okay. Right, the additional properties like fatigue and durability are also being discussed in the very last session. With that, we have closed the last session. Okay, so this is about the complete Unit 1 content that we have been discussing for last 17 sessions. So wherever you have uh, clarity is required, so go to that particular recorded lecture and have a detailed discussion over there what we have done. Still, if you feel that there is still something to be discussed, we'll have a online conferencing through Google Meet with the link that is available in the Google Classroom, right? So thank you. In the next session, we'll start with Unit 2 of your syllabus, where we'll talk about pre-stressing systems, half of the unit, and then how to calculate pre-stress value in the next half of the unit 2. Okay, thank you.